The next type of problems we're going to solve using systems of linear equations is combination problems. Combination problems are often written in standard form. So whenever you find that you read the problem and we're combining two different things together for a total, we want to write that equation in standard form. We have a jar of pennies and quarters. So our two items are pennies and quarters that we're combining together. You want to choose 20 coins that are worth exactly $3.30. How many of each coin do you have? Well, we know that we need 20 coins, and to make up those 20 coins, they're made up of pennies and quarters. So I'm going to use P to represent pennies, and quarters will be Q. The number of pennies we have plus the number of quarters we have has to equal 20. So that's one equation. The other equation we have is going to be talking about money. We know the total amount of money is $3.32. That's made up of the money from pennies. We know that each penny is worth 1 cent. So we can say 1 penny, 1 cent per penny. We can write that as a decimal if we're talking in terms of dollars. So 1 cent plus 25 cents per quarter is equal to $3.32. So this is our equation in terms of dollars. We could, however, rewrite this equation in terms of cents, multiplying everything in it by 100. So then it would be 1 cent per penny plus 25 cents per quarter, said equal to $3.32. Written in just cents would be 332 cents. We multiplied everything by 100, moving the decimals to the right. So I'm going to use this equation instead and write this directly underneath it just so it's easier to work with. So we have pennies plus quarters is equal to 20. Both of our equations are written in standard form. When they're written in standard form, we want to use elimination, especially when we have a matching coefficient. Right here for our pennies, it's a matching coefficient of 1. Because they are the same sign, they're both positives, we're going to subtract our equations. So we need to subtract each term. 1p minus 1p leaves us with 0 pennies then, so it cancels out. 25 quarters minus 1 quarter gives us 24 quarters, and 332 minus 20 gives us 312. Then from there we would need to divide by 24, leaving us with Q is equal to 13. So that's how many quarters we need. Then we can plug that number back into either one of our equations. In this case, we have 1, 2, or 3 equations we could use. I'm going to use this one because it's a lot easier to use. And we'll put pennies plus our 13 quarters, so 13 is equal to 20. And then we can just solve it, leaving us with 7. So we know that we need 7 pennies and 13 quarters to make up $3.32 exactly, using 20 coins total. And that would be our answer. Let's try another type of combination problem. This time we're going shopping. During a sale at the outlet mall, you buy 3 sweatshirts and 2 pairs of sweatpants for $85.50. That's one situation. Again, it's a system, so we need 2 equations. We're talking about sweatshirts and sweatpants. I'm going to use S for sweatshirts and P for sweatpants to solve. So we can say that we have 3 sweatshirts, 3S, plus 2 pairs of sweatpants. We don't know how much the sweatshirt is, so that's the sweatshirt cost and the sweatpants cost. But in all, that total is $85.50. That's the first trip to the outlet mall. Later, we return to the store at the outlet mall, the same store, and buy 3 more sweatshirts and 4 more pairs of sweatpants for $123, assuming that they are the exact same. So this time it's going to be 3S, because again, we don't know how much they were, plus 4P, because it's 4 sweatpants this time, totaling $123. So now, again, we have 2 equations in standard form. This is our first trip to the mall. This is our second trip to the mall. And we want to know the sale price of each sweatshirt and sweatpants, our variables. We have matching coefficients in our S term, and they're the same sign, so we're going to subtract them. 3S minus 3S is 0, so that term will cancel out. 0S. 2P minus 4P is actually a negative 2P. It's fine for now that it's negative. And $85.50 minus 123 gives us a negative again, but that's fine for now. $37.50. Now when we divide, it's by a negative number. It's important to show that negative, and we get P is equal to $18.75. Again, P represented the price for each pair of sweatpants. So each pair of sweatpants was $18.75. Now we can plug this in for either one of our equations up here. Doesn't matter which one. I'm going to use this top one because we're only multiplying by 2. Again, you could have chosen either one. So it'll be 3S plus 2P times 1875 is equal to $85.50. 2 times 1875 gives us $37.50. From there we can subtract. Leaving us with 3S, because this cancels, is equal to 48. Divide by 3, and S is going to be equal to 16. Again, S was the price for each pair of sweatpants, so it's going to be $16. So we know that sweatpants cost $18.75 each, and sweatshirts cost $16 each. Sounds like we should go shopping. And then this would be our solution.